Hey, Rani here. Shall we make a game? So last time we got this sort of working and that we can click and it's definitely placing the cube where we're clicking. But certain areas of the screen it just doesn't. It seems to like fly out of bounds. You know, it seems to be going over here to the left for some reason. It seems to be like a relatively sort of like narrow band of maybe half the screen in which it works. So today we need to figure out why. Why is it doing this? What's special about that depth range? So, how are we going to do this? I'm actually just going to commit what I kind of finished yesterday. That's a good idea. Yeah. Just we've got it working to this point. It makes sense to me to just kind of preserve what we have here. Yeah, I'm not committing that yet though. Committing that. That's good. 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 Yep. Okay. Hold that fort. Good and good. Well, not good. I don't like this design decision at all, but we'll stick with it, I guess. Okay. Implement world positions on click. Has bugs. Cool. All right. So our next step is we need to figure out. We need to actually get some numbers out of the system and figure out what's going on when it goes off the screen. So my solution to this is going to be. Let's see here. I'm just going to add a random. I'm going to add a header file here. And just going to do my normal header guard shenanigans. And I'm basically just going to put some global variables in here that we can write to from within the picking code, and then we can write them to the screen within the kind of advanced callback. So, I want to include my awesome header as well, just so I can get the primitives. Okay, so what information we're going to have? We're going to have, yeah, we're going to have the clip coordinates on X, Y, and Z. Let's do that as a vector, why not? And then we're going to have the world coordinates as a, yeah, okay, that'll do. And if we go to advance, we can then bring in that header. And I wonder if it's still got the, no, it doesn't still have it in the undo history. I'm going to have to write that code again to write stuff on the screen. Okay, that's no big deal. It wasn't that hard to write. Don't think it was anyway. Okay, top, left, top left corner. And we're writing it to the video buffer. Okay, that's all done. And yeah, I really need to write this overload to write floats because it is going to be something that happens quite a bit. Anyway, so we've got a clip space, and let's also write a bit of a blurb on this so we can see what it is at a glance. So we don't have to keep referring backwards and forwards. And hopefully we'll get some idea of where we're going wrong. Oh, I'm not specifying the font, am I? Oops. Do that every time, don't I? Okay, I really should have done a parallel build, but I'm going to have to make a C file for this anyway, so let's do that now. It'd be nice if C, maybe C does have a concept that's like a static, let's have a look, C static include. Actually, it'd be nice if you could like say include a header file directly into your current header file, but then like anything they brought in wasn't directly accessible from. Did that actually build? What? Doesn't make any sense. It wasn't a C file for this. Anyway, all good. Let's. Oh, well, I just realized I didn't actually multiply this by like 100, so they'll be very, very, very small numbers. Very small. Okay, there we go. Yep. So next up, we need to, in our selectable component, we just need to bring in the debug header over here. And then hang on. I just had a bug in another application. I'm just going to fix it. There we go. I'm not using the vector header here. That's quite surprising. Okay, so it doesn't seem to be anything special about the clip space coordinates at that point. It seems to just be quite sort of normal. And then like you get to there, it's not negative because that's actually negative and that's working. But as soon as it becomes very negative, it kind of breaks. And then with this side, it seems to be roughly when it reaches 0.5, it breaks. That's interesting. And the depth coordinate, because depth isn't very linear, it's basically always nearly 1, but it does vary a bit as it kind of flows over. Okay. Next thing to do is copy the world so we can see that, see what's going on there. It's definitely we're definitely getting something wrong there, but I'm not quite sure where it's going. Oh, it kind of snaps to 100. That's interesting. Why would it be going to 100? That's very weird. Okay. Let's go into here. Is there anything about this that would be... Oh, hang on. Hang on a second. I think I might know what it is. I think it's actually bouncing off the clip plane. Ah. Ah. Let's just have a look at... we did find something the other night that was... okay, unproject results for object picking. Okay, so... Okay. Let's make it so that when it hits one of these, it does something interesting. Let's say this. This should at least allow us to see which branch it's kind of hitting. I think it's probably hitting this one. No, it's going to be hitting this one. It'll be hitting, yeah, it's hitting two. Okay, right. It's incorrectly hitting this because it thinks that it's off the screen. Okay, what happens if I, yeah, is that even necessary, that branch? I don't know. Because that looks good. There we but just by printing out the numbers, we're able to see that like it was the range, kind of like, you know, 1 to -1 that was breaking things. Okay, that seems happy enough. Now I'm wondering why I even put that there, because Hmm. I wonder if that's necessary when things can go behind the camera. Let's find out. Let's go to go to here and let's rotate the camera a bit. Let's here it is. We've got an advanced thing in here somewhere. There it is. So now we just need to keep track of the number of frames that have passed. And I think this one here is the rotation. This might be a bit fast. We'll find out. Okay, yeah, that is a bit fast. However, I think I can see the bug that was put into fix manifesting. So we might need a slight variation on that clip function. So yeah, it is kind of like, see, this is kind of like flashing. That's because things behind the screen aren't being clipped. So if I put that clip test back in, yeah, it no longer happens. So yeah, we need that clip check when you're turning it into clip space. We don't need it when you're turning it back from clip space. Oh, so cool seeing that working. Okay, so let's go matrix header. Just remove that Z because it's never going to be clipped on Z now. And we just grab all this, make a new version of it, call it unclip. And then we can just inline this down here. Oh yeah, I should probably get rid of those debugging remarks I made as well. Just a second and that should be done. It's annoying when things aren't a general case when you thought they were, but at least we figured it out. We've changed the header files. We need to rebuild oops. Not help. Jobs. Okay, so next up, what do we want? We want to go to the selectable component and change this to unclip. And yeah, I'm just gonna slow this down like a lot more. So we can see what's actually going on. Build. Please build. There we go. So yeah, now we can click absolutely anywhere. And this isn't running at a low frame rate. It's just that the sine and cosine functions built into this engine are very, very imprecise. That works pretty perfectly. I'm happy with that. So next up, we are just going to commit those changes. It's just that one we want. The rest of it we don't want here. Yep, there we go. Oh, that's such a nice feature being able to just, pick out a single change. Fix picking, not working. So Z -1 to 1 range. Man, it's very fortuitous the camera is positioned and angled exactly like that. Otherwise I would have been scratching my head for a lot longer. Okay, that's working absolutely beautifully. So next up we need to get our kind of protagonist model on this cube. And I'm also going to turn off the spinning. It's making me a bit sick. Turns out it is not a good trick. Okay, that works beautifully. Okay. Our next step is to change this into an animated mesh. Where is it? Do we have any animated? Okay, we've brought in the header, that's fine. Do we have the protagonist? Yes, we do. Excellent. So I need to remember now. How this works. Animated paint mesh. Great, there it is. And there is no parent component. It's not selectable anyway, but it does block clicks. I need to take that into account. And then need the protagonist standing animation. And we do not want to call back when it completes. Oh, sorry, should that be a pointer? There we go. Ah, it didn't like something there. What didn't it like? It's the third argument. 1, 2, 3. Ah, it's the meta, the thing you can use to put thing you can use to sort of like link it to a particular record. Okay, that's kind of working. Looks sort of weird, but it's kind of working. One of the things is, of course, the lines don't currently have depth, so they're just drawing all over everything. Oh, that is so cool to see that working. It really is. Right. So next up, we're going to need a few things. We're going to have to be able to rotate this guy to wherever he's heading, and yeah, I think of the best way of doing that. Because I could implement the ATAN2 function, which is the one that given kind of like given you give it basically like 2 points in, well, you give it a point in 2D space, it basically gives you the angle. However, I could also just construct a rotation matrix, which isn't actually that hard to do. and I'm kind of tempted to do that. I am going to have to check out the inverse though for that inverse thing. Well, actually, that could be quite a useful. That could be quite a useful function in general. So I'm gonna do that. So we're gonna have IE void IE matrix. Rotation scale. That'll do. Actually, let's call it look at. Yeah, that's usually what it's called, isn't it? So just fix a slight typo in the comment there. Okay, so calculates a overwrites the rotation. Oh, actually no. Calculates a matrix which looks at a point in the world, looks at a point in the world from a okay. Then we're gonna give it a target. And yeah, we'll keep the scale. I mean, I don't plan on using it, but what the hell? We'll keep it. And we're also going to need an up normal. Actually, maybe I accept these as vectors. It's time for another kind of, like another sort of like, not necessarily hot take, but sort of big risky change. I want to swap over to using a proper vector type throughout. So they say a journey of 1,000 miles starts with the first step. Here's my first step. Do we have the, we don't have the vector header in here. Let's bring that in. And we've got that. Now, a good question is, how am I going to interpolate this? I've never actually implemented quaternions. How complex are they? Let's have a look at the article. Come on, Wikipedia. Break my brain. So, yeah, I know they've got 4 axes. Yeah, sure. I understand this. Yeah, I completely get all of this. This all makes perfect sense to me, honest. I'm not lying at all. Yeah, all I know about them is they can represent any arbitrary rotation in 3D space. Maybe more, I don't know. And they can be interpolated perfectly. But I know nothing else about them, and I'm looking at this and I'm like, to hell with that. Vector indicating and we'll include the scale now, why not? All right, okay, now we just need to fill these in. And now we implement it. The easy bit, right? Right? It's the easy bit. Okay, so we're going to need some new tools for this. So if I go to my Object-C, I should have the cross product in here. I'm going to replicate this. So let's go to our vector header. Calculates the cross product of two three-dimensional vectors. And he's just got an A, a B, and a result. Yeah, okay. First vector to cross product. Is it cross multiply? Hang on. What did we say about dots? Yeah. And let's again have a look at a dot product and copy. There we go. Ah. Longer term, this will kind of permeate throughout the code base. In fact, that might be a thing for the rewrite. Well, not the rewrite, the kind of rework. Is to really kind of get that everywhere. Okay, that's good. And then we can just basically steal this code and stick it in here. Oh, yeah, I should also mention you're allowed to reuse the input. Easy. Okay, next step is we need to be able to, I think we need to be able to normalize. Yes, we need to be able to normalize. So to do that, I am going to need a square root. Now, I have written a tiny amount of assembly, inline assembly in here. So I know that I can reach the dedicate square root instruction. But I'm not entirely sure how you pass arguments in, so I'm going to have a bit of a look into that. So let's go to our math header. Let's look at the, I want to make sure I name this correctly. What do you call the input to a square root? Oh, they just call it X. That'll do. That's fine by me. Here we go. We're going to write some assembly. Now, I ideally want to be able to test this pretty well. So I'm actually going to make use of that debug header I put in. And just write some numbers to it, see what happens, I guess. So we're going to want to call into our assembly, and I assume we want to put something onto the stack somehow. So yeah, we basically load it onto the stack and then we use it. So if we're doing inline assembly in here we are. So it looks like you can do something like that. I mean, this looks like it might be different, different syntax. What? Archive, log in to view this content. You what, mate? Give me the codes. WebAssembly's not a stack machine. I thought it was. Hang on. Tell me more, tell me more. The difference between a stack and a register machine is essentially this. A stack machine pops values from and push values onto a stack. So for example, an add operation will pop the last two values off of the stack, add them together and push the result back into the stack. A register machine has some number of places where values can be stored and operations read and write to those registers. Okay. Oh, I didn't know WebAssembly did all this. Oh, that's interesting. Right. So I'm using Clang. Let's see how you do. Because I know there's multiple different ways of kind of interfacing. Oh, they're actually defining an entire function in there. That could actually be really good, actually. Maybe I do it like that. Yeah, maybe I don't actually call it a function at all. Right, I'm gonna have to look at the I have to look at the syntax. I don't know whether it'll be aware of functions I've defined using inline assembly. It's a shame WebAssembly Studio seems to be dead, right? That was a really good tool. It seems to be just dead, which is a shame. Oh, I wonder if Compiler Explorer. I wonder if Compiler Explorer can show me the WebAssembly for like a basic function. I just want to see like roughly what the syntax would be. Let me just check exactly what I'm using here because I'm not sure myself. So I'm using Clang. What version are we using? We're using 16. Okay. See if we can find that. There it is. And our target is WebAssembly 32. Hey, that's pretty nice. Hey. So I wonder if I can come into here and I can just basically write this and whether it'll actually work if I do that. Right, that's doing a lot of stuff. You wouldn't think it'd be that involved to multiply the same number by itself, right? You think it'd be kind of like a... Oh, I guess the complication is... Right, you wouldn't have like a copy function on the stack, right? You think you would, though. You think you would. Okay, so let's say that... That's kind of weird. Let me just get rid of this parameter here. Right, yeah, so it says here, here's a constant. Okay. Set it, then get it. That's kind of weird. You think you'd be able to just return? I guess not. Anyway, Okay, so what we're trying to figure out here is exactly what it would do. To generate this code. So square root. And let's give it a float parameter. This probably, spoiler alert, this is probably not going to work. Do I just like put multiple of these in? I've not written much inline assembler, just in case it isn't obvious. Oh, you can just continue the string like like in other languages. That's fair. Yeah, the tooling in Visual Studio Code has no idea what the heck I'm doing right now. So I see it's doing an end function thing. I don't know. I don't think that's a real WebAssembly. I think that's like some kind of helper thing for Clang to know what the hell's going on. So let's say we did this. Oh, the other thing I'm going to do actually is I'm going to turn on optimizations because that might, you know, some of this might be just some kind of ugly looking code that's been. Whoa. What the heck? There we go. What is that? Why is there a constant of that there? That's weird. Oh yeah, another compression is that we're actually doing a cast by accident. Okay. Now that is more like what I expected to see. So yeah, we're basically getting the first sort of parameter. Okay, all right. So we can call local.get. So we've just fetched the input onto the stack. Yep. And then we're going to call that f32.sqrt. And that should work. Let's find out. Oh, it helps if you're like, yeah, include your files in the right place. That usually helps. Oh, it didn't like something. It's just saying this isn't filled out yet, which is correct. It's right. We'll come back for that later once we've got a working square root function. We're going to need it to normalize some vectors. Okay, it seems to be building. Now, we need to try and actually call this. So let's go to our advanced helper. And let's just scribble this out. So let's say that we're going from 64 and we're then going to, oh, I saw an error, I think. Yeah, it didn't quite see what it didn't quite understand what I was doing there. It's okay, I don't know what I'm doing either. Do we have the math header here? No, we don't. Let's bring that in. Unexpected token in operand. Looks like I can't quite do that. However, I can probably put this back in and just do this. Probably. I've got no idea. Ah, we need to notify that it's not being used. There's probably a way that I can pass that into there properly. Okay. Clang, WebAssembly, inline. Thing is, I don't really quite know where where I'd be looking for sort of the assistance with this. Ah, a good meme, I guess. Okay, so, ooh, what is happening here? Wow, what the heck is happening here? Okay, that's the output. So I'm going to have to define a local variable here. And then... what on earth does that mean? So I guess I can do this, whatever this is. I'm not optimistic this will work. Wait, is that seriously going to compile? I don't even know what that does. Okay, let's get rid of that, as that's causing some problems. I think I need to terminate those with a semicolon, I think. Yeah, oh, it's built, it's built. Let's see what it does, let's see how it crashes. Yay, it crashed. Okay, let's inspect what we got. Okay, expression has type I32 but expected F32, so it's probably that this needs to be something different, right? Oh, we probably don't need that anymore. I think. I have to see what it actually, we can have a look at what this actually generates. Popping value from empty stack. Okay. So let's have a bit of a look at what local.get actually does. Loads the value of a local variable into the stack. So we're definitely passing in a float. The problem is I'm not 100% on... Not 100% on how any of the syntax actually translates into... So obviously, this is being written for an x86 CPU, which has discrete registers and isn't a stack machine. Well, isn't. I don't think it's a stack machine. It has a stack component to it, but I don't think it's actually a stack machine. Um. Oh my god. Let's see if we can find what we've found so far. Nope. Nope, that didn't find anything. Ah. Okay, Clang, WebAssembly, inline example. And maybe we include that too. Oh. Ah. Aha. Not I'm finding much in here about WebAssembly. Input operands. Okay. So do we not need to specify a type when we're doing this? Oh, hang on. Maybe I need to do a set afterwards. Yeah, people who actually know how this works are internally screaming right now, going like, no, what are you doing? What's he talking about? Oh, yeah. Oops. Okay, that's not working. That's fine. What if we did a local get one instead? Okay, that's not working. So maybe instead we should comment this out for the moment. So we've got a kind of copy of it. Let's try just loading a constant in instead. Let's see if we can get a constant value out the other side of this. If we can do that, that's probably yeah, that's probably good. So yeah, we can load in a constant like this. Give it to the output, and that might work. And then we're not using the inputs. We'll just tell it we know we're not using the input. And I need to specify that it's a that it's an input or an output, I guess. Oh, didn't like that. Fine, I guess I'll just take this, whatever that's supposed to be. Okay, unused values not explicitly dropped by the end of the block. So I guess I then need to I need to add that to the stack somehow. I need to take that out of, well, I need to somehow get this off the stack into this. So I would guess that would probably be local.set, probably. Type has F32 but expected I32. Why? Why do you expect that? So what does this actually mean? See if we can find the definition of this. What do you mean you can't find it? I copied it off this page. Okay, output operands. Here we are. What happened there? So in that case, they're using a bool for it, so that should be fine. Yeah, they're able to pull in a float there. So that looks fine. I might have to see what this is actually doing. Oh, actually, I tell you what we can do. Something just occurred to me is we can actually just paste this to the compiler explorer and see what it does. We can see exactly what it's doing with our code and see why it may or may not be working. Nope, that's still not working. Yeah, why is that calling get one? That wouldn't make any sense. Let's just keep poking at this until it does something that seems rational. Unused values not dropped by the end of the block. What do you mean by this, compiler? What do you mean? Ah. Loads the value of a local variable into the stack, and I'm going to guess local set if I just duplicate this tab. All I want is a square root. Ah! Sets the values of a local variable. So, okay, so I wonder if because this is implying that these are. Oh wait, this is in what? It's not in normal WebAssembly. How the heck does this work? Oh my god. One of the things about WebAssembly is not a lot of people seem to be getting into the nuts and bolts of it, which is quite annoying. It's quite difficult to find tutorials online or like examples that don't use like really big overbearing frameworks, is what I'm trying to avoid. Specifically so I don't get like tied to those frameworks. So when they're inevitably dumped or updated in the way that makes them basically a different framework, I'm not sort of left behind. But this does come with a slight issue. Okay, I've got an idea. Let us that's interesting, not doing any kind of local.get stuff or local.set stuff. I feel like this is not actually, this is some kind of like not quite real WebAssembly, but some kind of like pseudocode sort of thing, where it's kind of like, if you embed it in a different context, it would be valid WebAssembly, but it's not standalone WebAssembly, if that makes sense. Why is this red? What does that mean? Are you gonna make it red and then not explain why it's red? I mean, fine, I guess. Okay. All right. How do I resolve this? How do I figure out what the hell's going on here? So I'm just going to have a bit of a think about this. Hmm. How the heck does any of this link up? Let's keep playing around, see if we can figure out. So this should be an output. This should be being set to 1. Now, I don't really want to upload the entire binary because like it'll take like years to find anything in there. Unused values not explicitly dropped by the end of the block. Okay, so that means that we have to do something with it. Be nice if we could just find some like simple examples of just all I want is a simple example of just someone calling into this with an input and an output. That's all I want. Yeah, if I could just see an example of it, I'd probably understand it. But like just having like a like a 30-page document doesn't really help. But yeah, most of which is talking about x86 and not WebAssembly. This isn't on this page. Why are you giving me this? This isn't talking about WebAssembly at all. Well, it is like nobody on the web is like using is using WebAssembly with inline assembly. I just want a simple example. Some of these things were like a 2-line example showing me how to connect these things together would make this obvious how you use it, but I'm not going to get that. Okay, what if I put something daft in there, like say 5? What happens then? Right, so let's try and fact check here. So this is saying an expression has type float but expected integer. Why would that be the case? It's saying it has a float but it's expecting an integer. Let's have a think about this. Float, float. There's no mention of an integer anywhere in here. This should be a float constant. And then we're using local set, which to my knowledge doesn't actually have a type in it. Yeah, this doesn't super help because they're... I wonder if this is making a local that's an integer. If it is, that's not super helpful. It'd be really handy if like there was just some example on the web of how what this actually kind of does. But they're all specific to oh wait. No, this is again specific to x86, which I'm sure is useful to most people. It's not useful to me. I can't believe I haven't found just an example of this just in those quick searching. Normally you find an example really quick. Okay. Again, like, people just go, like, way into depth, and I'm like, I just want to know what the syntax is. I just want to know how I specify the type of the return value. That's all I want. Okay, output operands. Okay, there we go. Okay, that's fine. Constraints on the placement. Well, it's not the placement that's the problem. It's the original operand. Okay. An immediate floating operand. That's probably what I want. That's probably it. No, of course it wouldn't be that simple, would it? It's like, can you at least tell me what is allowed? Ah, just tell me what is allowed. Okay, so there's going to be some kind of machine specific. Where would I even find this? Like, you know, where would this even be documented? Because you go to the assembly documentation, it's talking about x86 assembly. Where would I even go to find this information? This is the problem. Is it like, I know this information exists somewhere. I know that someone has documented it. I couldn't even begin to tell you where. Okay, let's have a look at this. I've avoided using it because it's a big, it's a big heavy framework that's probably going to be, that'll probably become eventually irrelevant or something. But let's see if there's anything useful in Inscription. I'm not saying it's bad. It's just saying like, I don't want to use it because I'm trying to avoid like bringing in these massive dependencies that inevitably kind of either change so much they're not the same thing anymore, or they get abandoned and replaced with other things. Usually there's like a thing in here that breaks down the languages, right? Where is that? Where have they moved that to? There it is. So let's have a look in the C. Okay, all right. So what I might do is I might pull this down and just search because I'll just try this first. I'm not hopeful. Oh, it actually worked. Okay. So let's look at Indian nurse. That's fine. What does that mean? Okay, what? What are they doing that? Wait, do I have to do that? Oh, we've got number 3 out. We've got number 3 out. Okay, next up. We need to see. Once I had a simple example of how to use it that was actually relevant, it took almost no time at all to actually figure out what the heck I needed to do. But until I got that, I was like, I was going to struggle. Okay. That compiles. That doesn't tell us much, but it compiles. There we go, working square root. Oh man, as per usual, like about 2 minutes, actually implementing it, and about 20 minutes trying to find a rational example just telling me how to use basic syntax. That's neat. Yeah, we can't click through. Okay, it's working nicely. Okay, let's commit that because that is neat. So we can actually add a few more functions to our vector thing there. So we've got the cross product. We should probably have normal, kind of like a normal between. Calculates the normal vector between 2 points. The point from which a normal vector is being calculated. I'm going to have a destination. The point to which a normal vector is being calculated. Overwritten with the normal from origin to destination. Maybe origin and or B. What do we have in there? Remark. Behavior is undefined when origin and destination are equal. That'll do. And because we're doing, I'm going to stick with this just because it's consistent with the rest of the code base. Let's put in this annoying lemp thing. So this is going to be dead simple. Super simple. Basically subtract. Oh, I didn't rename these in here. Oops. And we don't need a length argument as these are the vectors with fixed length, so we can use that. Okay. Okay, so now we have that. And I'm actually going to add a normalize function. I think that'd be helpful. A vector normalize. Calculates a unit length. Hang on. Resizes a vector to unit length. Param input, the vector to resize. Param output, the input vector resized to unit length may be input. And I'm going to implement that super fast. And again, we can add another helper here. If it's undefined when when input is 0 length, it's fine. I'm going to calculate the magnitude of a vector. And rather than calculate, it's measure. And we're going to want to do the square of the as well, because that's actually very useful. Measures the square of the magnitude of a vector. Oh yeah, and these also return. Man, it's annoying how much time I've lost today, but at least we've tackled the hard problems, right? Okay, this is dead simple. It is literally input. Hang on, let's get the X. It is basic Pythagoras theorem without the square root. So it's just x multiplied by x, y multiplied by y, z multiplied by z. And the magnitude is literally just the magnitude square. I'm going to bring in that math header. And then we just get the magnitude squared, input, dead simple. Easy. Right, and then we need to get the magnitude, which is going to be, just call what we defined above. And then just divide all the axes by the magnitude. Okay, so now we have the difference, and then we're going to normalize it. Easy, super easy. Okay, so we're going to use this in our matrix file. Let's remember what I was even working on. Matrix. Okay, so for now, I'm going to put in this do for the inverse, just because I'm probably not going to get around to doing that. So I'm just going to steal this. Now we're going to do our calculations up here. So one moment. Okay. Yeah, forward normal, and then we're going to get the normal between. Location, target. Maybe I should call those origin destination too. I'm not sure. And then we're going to write it to the forward normal. So now let's just get a sprite out and start drawing this up. So we have a point in 3D space, we have the point where we're going, and we've now made a vector that points along there, and we have our up vector, but they're not necessarily correlated. So what we have to do is we have to calculate the cross product of that and that, right, to get the side vector, which will then be it's perpendicular, isn't it? Yeah, and then we do the cross product of this and this to calculate the true up vector. So we're going to use those handy little functions we just wrote. So it's going to be the forward normal with the up normal. It's going to produce the side normal. And then cross product the forward with the up, so with the side to produce the up normal. Now this might end up being inside out, back to front, whatever. We'll just fiddle with it till it works. So again, we copy the location over into here. Nice and simple. Now first of all, we've got the side normal. Now, if I was an optimizing fellow, we could actually directly, rather than making these temporary variables and copying them across, we could actually use these as the targets of these. That would be kind of neat to do. So this is our up normal. That's fine. Oh, we also need to normalize all of these. I nearly forgot. Now, chance that's working first time, pretty low, pretty low. It's going to be inside out or back to front or something. Yeah, we're also not currently calculating the inverse, and we're also not calculating the scale. So that will come later though. So that should build. Okay, that's good. And now we go to our scenario script over here, and yeah, we've got this part here. We've got the next location. So instead, we're actually going to call into matrix look at. It's going okay. There's still many of them. All good your end? Where's the target? Where is it? Man, that's a game that I've not really had a look at, but it looks like it's quite big and impressive in scale. But it's one of those games that's going to take so long to finish, if it ever even is finished, that it might be obsolete by the time it is finished, you know? What's this talking about? What's this all about? That's a matrix power, isn't it? Oh, I need to dereference it. Okay, there we go. Right, let's see what that does. Okay, so we know this route isn't being hit because it's wait, is there an error somewhere and it's just been masked in all the... No, there's not. Oh, this is the... Hang on, let me pull this back. Let me pull this back. This is the kind of like catch-all case. Damn, 20 gigs of RAM. What happened to this industry? What on earth happened? Wasn't that long ago. I was developing on 2 gigs of RAM. Oh, 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 yeah, we've got some messed up looking geometry there. Yeah, something's definitely not working. I mean, it's probably barely even visible. It's kind of like just a twisted, mangled pile of pixels that's meant to be where we're... I do wonder if in the case of Star Citizen, where didn't they have like entirely different studios build different parts of the same game? That sounds actually impossible to kind of organize and keep running. I wonder if I need to transpose these. COD is one where I'm amazed. I cannot believe someone has actually built a game that big. And I don't know where all the space has gone. I haven't really played it myself, so I might be, missing something about it. But every time I look at it, I'm like, wow, that's big. Ah, here we go. 10. I did a copy paste and didn't update the indices. Okay, I'm still not seeing. Oh wait, he's upside down. Okay, so we just flip these two arguments, and it should flip in the right way up. Hey, that seems to be working. All right, okay. So next thing I just need to double check is whether whether it's flipped. So let's the stick should be in the right hand. I think it's in his. It's kind of hard to see, but I think it's in his left hand. Probably help if the background was kind of light, huh? Let me fix that. Oh, I can't see anything. Right, this is going to look terrible, but it's just temporary, just while we figure out what's going on. Yeah, you go back to the PlayStation 1 games, and like, yeah, it's flipped on the x-axis. And PlayStation 1 games, most of those are tiny. They're like, the actual game part is 20 to 30 megabytes, and the rest of it's all music and stuff generally. Yeah, music and videos. There we go. Oh, and now he's walking sideways. That's interesting. Okay. Oh, hang on. What is going on here? He's not consistently backwards. It looks like he's rotating the wrong way. Let's try flipping these two around again. I mean, like, I know this is a game developer thing, where it's kind of like you just keep flipping arguments around until like it does what you want. Because John Carmack makes jokes about this, so yeah, it looks like it's just wrong on one of the axes. Hmm. Hmm. So a quick look for this to make sure I'm not doing anything obviously stupid. I probably am. That looks good. I wonder if I might need to flip these around. So like this. I don't think I do. But it's worth having a quick look. Okay, and these should all be 2. These should all be 1. Oh no, that's that's turned him into a very, very, very flat person, which is not what we wanted. Let's double check here. Side, up, forward, side, up, forward, 2, 2, 2, 1, 1, 1, no, no, no. That should be right. I can put that back out was it was closer before. Now, what I might do is draw some lines out of the sky so we can see where it's actually plotting this. Definitely looks like it's backwards on X only, which doesn't really make a lot of sense. Unless I had the side normal backwards. And then the up normals backwards. So that looks right, except the stick's in the wrong hand. So if I just flip the side normal, let's see what that does. See, that looks vaguely right, but now he's, again, it's flipped on the x-axis. Why would that be flipped on just one axis? That doesn't make a lot of sense. Hang on. Let's just have a look at this code. It's been a while since I've written this and I've completely forgotten how it works. Let's just have a look at this. Let's check these about 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, those are right. Is the product... Oh, get out of here, Visual Studio Code. Get out of here. Is the cross product code good? That all looks right. That looks right. So why no work? What happens if I just inverse all of these? What happens then? Just basically clutching at straws now. See, that fixes it. And the question is, why does that fix it? Why would that possibly fix it? I'm a bit of a loss as to why that fixes it. Oh no. What is special about the x-axis that needs flipping when none of the other axes do? Let's make sure that it actually works in some less trivial cases. So now he should be kind of like looking up slightly the whole time. Okay, it's definitely not working. Okay, that's actually good. That implies there is something more going on for me to fix. Uh, okay, let's put it back in without that flipped and we'll see what happens. Yeah, he's kind of leaning over the wrong way. I mean, maybe I do need to do that thing where I kind of like flip the, you know, almost kind of like do the, what do they call it? What do they call it? I've gone blank. It's when you, oh, transpose the matrix. Okay, that's actually doing what we expect now. Stick's still in the wrong hand for some reason, but as he's getting, because I've basically made it so that the target point is a meter above where it should be. So as he gets closer, he kind of like tilts back because he's looking up to, he's sort of aiming up to look at it. So our side normal must be backwards. So let's flip that around. This will probably make him stick through the ground, but we can fix that later. That didn't reload, did it? Yeah, okay. And then we flip the up normal by swapping these two arguments around. And now he's holding the stick in the right hand, and he correctly leans back as he approaches the target that's slightly above him. Well, that is working kind of beautifully. Okay, so next steps for this, which, because I might be stopping in a second. Next steps for this are, at the moment when he gets extremely close, there's like a bit of numerical precision breakdown because his location starts overlapping the actual target. So maybe I need kind of like a distance check on that. And maybe I can actually have this sort of return whether or not it actually managed to do a distance check. I need to make it animate. I need to come up with a slightly better approach so it doesn't do this weird kind of like pulsing thing when it reaches the edge of a face. However, I'm just going to roll back that texture. It's really it's destroying my eyeballs. Do a build. There he is. Anyway, thank you very much for watching. That was some good progress, even if it wasn't a lot. Have a great Saturday.